Golden ratio has been a mathematical interest for 2,400 years, attracting the likes of Pythagoras and Phidias, represented by the Greek letter phi from Phidias. Two quantities are in the golden ratio if their ratio is the same as the ratio of their sum to the larger of the two, i.e. a plus b divided by a is equal to a divided by b, or phi. This is an irrational number, a number with infinitely many decimal places. It is also a solution to the quadratic equation x squared minus x minus 1 and can be represented by the surd. The golden ratio is also linked closely to the Fibonacci sequence, which is mentioned later on in the video.
There's many examples in nature of the Fibonacci sequence. The number of petals in a flower is often a Fibonacci number. For example, there are 3 petals in a lily, 5 in a buttercup, and typically 34 or 55 in a daisy. Each petal is placed at 0.618034 per turn for optimal sunlight exposure, which is approximately equal to dividing a number in the Fibonacci sequence by the number that follows it. Human faces display ratios similar to that of the golden ratio. The mouth and nose are each positioned at golden sections at the distance between the eyes and the bottom of the chin. Similar proportions are seen from the side profile and also the eye and the ear themselves. The human body parts are also based on patterns of 5, that's a number in the Fibonacci sequence. For example, 5 fingers and 5 toes and 5 openings on the face. In trees, the main trunk will grow until it produces a branch, which produces 2 growth points. Then one of the new stems branches into 2, whilst the other lies dormant. This pattern of branching is repeated for each of the new stems, as seen in the diagram above. The tree begins to form a Fibonacci sequence with its branches as it grows.
Now I will introduce the application in architecture. The golden ratio appeared in architecture perhaps as early as the Great Pyramid of Giza and in the Parthenon of the Acropolis in ancient Athens. Now I will illustrate some application in some of the most notable buildings in the world. The first is Taj Mahal. The Taj Mahal displays golden proportions in the width of its grand central arch to its wings, and also in the height of the windows inside the arch to the height of the main section below the domes. And then the Parthenon. The Parthenon displays golden ratios in the height of the cross beams in relation to its height, and also in the rectangular design below the sculptures. Each application of the golden ratio is different and unique, but each adds to its overall architectural beauty and harmony with the design principles found in nature.
This part is about economic applications of Fibonacci theories in our real world. Here is the part of Fibonacci sequence from 011 to 610 to infinity. Each number is approximately 1.618 times greater than the previous one. From this sequence, we get 3 important golden ratios: 0.618, 0.382, and the last one, 0.5. Our question is that how can we use these 3 important ratios to predict a price level? Here is the example. We assume that this curve is the price level in the investment market. This is the price of a stock. This point is peak at 4.1. This point is our current price, 3.03. Our question is, what is this point? What is the possible price level in the future? Here is the method. Possible price level equals to current price plus peak minus current times golden ratio. Obviously, this is the most simplest and roughest way to predict future price level in the investment market. When we apply golden ratios to real-world investment, we should combine with other techniques to make this prediction precisely.